Okay, now we are going to discuss another important topic that is called flow control. Okay, that is called flow control. As we know that when the sender machine, when the receiver machine, it receives the data from the sender. So the data is passed through the physical layer. The physical layer, then it is passed through data link layer. Then it is passed through to IP layer. The IP passes this data to transport layer. In the transport layer, TCP there, suppose. So here the TCP, it's received the data. If the data is in order and it is correct, then that data is stored here in the buffer, and from this buffer the application, it reads the data. Okay, so suppose that the data arrival rate from here, from the sender side, it is greater, it is larger, and the application process, it's reading the data from this buffer, it is slow. So the application remove data from the TCP socket. So here the data is stored in the TCP socket, and from the TCP socket the application, it reads the data. When the data is read by the application, then this data is removed from the receiver buffer. That is, the data is moved from the buffer to the application. So here the space becomes empty, it becomes free. So suppose from the sender 4 packets are arriving per second, and the application is reading 1 packet per second. So 4 packets are arriving, 4 packets are stored, but 1 packet will be read by application, then 3 packets will be stored in buffer. Okay, so for example, in the first second 3 packets are stored, in the second 3 packets are stored, in this third second 3 packets are stored, and so on. So this buffer, there is a receiving buffer. What is receiving buffer? That when the sender sends the packet, the receiver process these through this layer, and after processing, and there the data is correct in order, okay, and ready to be delivered to the application, then it is stored in the receiver buffer. If this receiving buffer, if the data arrival here is faster and the application is reading slowly, so some data will be stored in buffer. But this buffer, it has finite space. Okay, so when this buffer is full and more data is arrived from the sender, and the buffer is full, then what will happen? Then that data will not be stored, that will be discarded, that will be lost. When that packet is lost, then ultimately its acknowledgement will not be received to the sender, so the sender will retransmit it. Okay, so this TCP receiver, it has a buffer, it has a receiver buffer, and it has a space, it has a finite space. Okay, so the flow control, what does it mean? The TCP flow control means that the receiver controls sender, receiver control the sender rate, receiver tells this free space to the sender that at this time I have, for example, 4 packets free in this buffer. So the sender can send 4 packets. If the sender sends more than 4 packets, then they will be discarded. Okay, so the flow control, it basically enables the receiver to control the sending data rate. Okay, and how it is controlled? The receiver informs the sender that I have 4 packets free space, so the sender can send 4 packets, not more than 4 packets. So flow control means the receiver controls sender so that the sender will not overflow the receiver buffer by transmitting too much too fast. Okay, so how it is controlled, we will discuss it. So the flow control means that the sender should send that amount of data to the receiver that can be accommodated in the receiver buffer. The sender should not send the data that cannot be accommodated in the receiver buffer. This is called flow control. Okay, and basically the receiver tells to the sender that at this moment I have this much free space. If the receiver tells that I have zero free space, then the sender will stop transmission. If the receiver tells to the sender that I have 8 packets free, 8 packets free space in the buffer, then the sender will send 8 packets. Okay, not more than 8 packets. Okay, so we will discuss how it happens. So first you should understand flow control, that in the TCP receiver there is a receiver buffer. And what is the receiver buffer? When the packets are arrived from the sender, they are processed through the layers and they are ready to be delivered to the application. Then they are stored in the TCP receiver buffer, and the application reads the data from the TCP receiver buffer. When the application reads the data from the receiver buffer, then that space becomes idle in the receiver buffer. Okay, so if the data rate from the sender is larger, if it is greater, then the application process read the data from the TCP socket, then some packets will be stored in the receiver buffer. But this receiver buffer is finite space. When it becomes full and more packets arrive, then those packets will be discarded. So to avoid this overflow of receiver buffer, we use TCP flow control. Okay, so let's discuss how TCP flow control works. Now, as you know that the TCP segment structure, we have discussed source port number, destination port number, sequence number, acknowledgement number. This receive window, it is used for flow control. Whenever the TCP sender or receiver, because the sender and receiver in the TCP, they both can send data to each other. So each time a packet is moving, the TCP, it includes receive window, that how much space is available in the receiver buffer. So the receive window, it indicates the number of bytes a receiver is willing to accept, and how much bytes they are willing to accept depending upon the free buffer space, that how much free space is available in the buffer. Okay, so basically when the receiver sends the acknowledgement or receiver sends the data to the sender, so the receiver tells that how much free space is available in the receiver buffer. Okay, so this free space, it is basically set the value into this field of the TCP. Okay, into this field of the receive window. So this field in the TCP, it is used for flow control, and it indicates that much amount of receiving the receiver can accept, that is that much of byte space is available in the receiver buffer. Okay, so let me explain it through an example. Suppose this is host A and this is host B. This is the receiver. Okay, so suppose when host A and host B, they establish connection. So host B informs to host A that host B has 30 byte free space. This is the receiver buffer space, and it is 30 bytes at the host B. This is the receiver. So host B informs to host A that host B has at the moment 30 bytes free space available. Okay, so suppose the host A, it sends 2 packets. You can see packet with the sequence number 92 and it is 8 byte, and next packet with the sequence number 100, it is 20 byte. You can see that 8 plus 20, it is 20 byte. It is less than the receiver buffer space, so it will be accommodated in the receiver buffer. Okay, so the host B controls the sender by sending this free space, that host B informs to host A that at this moment I have 30 bytes free space in the receiver buffer. So the host A will send the 30 bytes maximum data, less than 30 bytes, not more than 30 bytes. So you can see that host A is sending 2 packets with the 8 byte and 20 bytes, so it is 28 bytes. So it can be accommodated here in the buffer space. Okay, suppose this packet is received. Okay, when it is received, so this is the first packet. Okay, so it will wait for 500 milliseconds. It will wait for 500 milliseconds because this is the first packet and not acknowledged. So we have discussed the TCP reliability, that it will wait for 500 milliseconds. If next packet is arrived, this single acknowledgement will be sent. Okay, and this packet is stored in the buffer. So this packet with the sequence number 92, it is 8 byte. So 30 bytes free space was available. Now 8 bytes is occupied by the packet with the sequence number 92. So 22 bytes free space is available. Now suppose the this 500 millisecond time it is expired. So the host B will send the acknowledgement. When the host B sends the acknowledgement, so acknowledgement for this packet will be acknowledgement 100. Okay, acknowledgement will be 100. But in this acknowledgement, the host B will include receive window. Receive window means the free space in its receiver buffer, that this much amount of data host B can accommodate, is willing to accept. So the receive window will be 22, that now 22 bytes free space is available. So this will be announced. Okay, now you can see that when receive acknowledgement 100 by host A, so also in this acknowledgement there is receive window 22, that is 22 bytes free space is available. Okay, so now you can note that host A has sent another packet that is with the sequence number 100, and this packet is not acknowledged. Okay, and this is 20 bytes data. So this 20 bytes will be subtracted from receive window. So 22 is the receive window and 20 byte is sent, and it is not acknowledged. So the unacknowledged data, it will be subtracted from the receive window. So it will become 20. So now the host A can send only 2 byte. Although the receive window is 22, which means that 22 byte, but the 20 byte is already sent. So if the 20 byte is also received, so because the 20 byte its acknowledgement is not received, so it means it is on the way. When it is also received, then this buffer space will have 2 bytes space. So that's why the host A, it is subtracting the unacknowledged bytes from the receive window. So 2 bytes are sent. Okay, so if the 2 bytes are sent and the 20 bytes are also received, so 2 plus 20, 22 bytes will be occupied. Okay, if the receive window is 22, if the sender sends 22 without subtracting the unacknowledged bytes from the receive window, if the sender sends 22 bytes and this 20 bytes are also arrived, then 20 plus 22, 42. So 42 bytes, and there is free space 22 bytes. So the 22 bytes will be accommodated and 20 bytes will be lost. So that's why this unacknowledged bytes, they are subtracted from the receive window. Okay, so the sender sends the next packet, third packet with the sequence number 120, and it is 2 bytes of data. Now suppose that this second packet is arrived, its sequence is 100, it is also stored in the buffer, suppose. Okay, so when it is stored, so 8 plus 20, 22 bytes. Okay, because 8 byte is packet with the sequence number 92, and 20 byte is a packet with the sequence number 100. So 28, so 2 bytes free spaces are available. So when the host B sends acknowledgement, so it will include 2 receive window to 2. Why? Because the 2 bytes free space is now available. So this will be announced. When this is announced, so the sender subtract the receive window from unacknowledged. Now this is received. When the acknowledgement 120 is received, so it means that this 92 and 100 packet, this second packet is also received. Okay, so now this packet is remaining unacknowledged, and this packet is of 2 bytes. So this 2 bytes will be subtracted, and it becomes 0. So it means that the sender cannot send any more data, so it will stop. Okay, now suppose that this third packet, it is also arrived, and it is stored in the buffer. So it means that now 8 plus 20 plus 2, so 3 packets are arrived, and they are 30 bytes. The whole 30 bytes free space buffer is occupied. So in the buffer we have 0 byte free space, 0 byte free. So therefore when the host B sends acknowledgement for this packet, so the receive window will be 0. Why? Because here the 0 bytes is free space occupied and the acknowledgement is sent. and acknowledgement will be 122. Why? Because it has the sequence number 120 and it has 2 bytes. So with the first byte with the sequence number 120, second byte with 121. So the acknowledgement will be 122, because in the TCP we sends the acknowledgement number for the expecting byte. So the next, now the receiver is expecting the byte with the sequence number 122. So the expected sequence number will be sent as the acknowledgement number. Okay, and the receive window will be 0. Okay. Now the receiver is the sender, host A is waiting, is receiving window 0, so it cannot transmit any more data. Now also you can note that up to now the host B has sent all bytes acknowledged, and they are stored in the buffer. Suppose the application, it reads the data. Application 30 bytes of packet, they are delivered to application. If they are delivered to application, then this buffer will become free. Buffer become free. Now the buffer is free, but the receive window has received 0, and the sender has host B, it is the receiver, it has acknowledged all the packets. So how the host A come to know that this buffer is free? Host A cannot come to know, because there is no acknowledgement moving from host B, because the receive window is sent when there is packet moving from host B to host A, and now host B has acknowledged all the packets, so no acknowledgement is moving, and host B is not sending any data. So host B is not sending data, so it means that no packet is moving from host B, and there is host A, it wants to send the next packet, but it cannot send. Why it cannot send? Because it has received window 0. Host A has the data to, host A wants to send data, but it cannot send. Why? Because host A has received window 0, and now there the free space is available. Now the buffer has free space 30 byte, but it is not known to host A, because when host B announce it, then host A comes to know, but host B is not announcing. Why? Because host B doesn't want to send any packet. Why? Because host B has already sent the acknowledgement, and host B doesn't want to send data. So in this case, the TCP has a solution. That is the solution, that when the sender or when the host A, it receives the receive window 0, so after some time the host A will send a packet with 1 bytes of data. Why? Because if this bytes of data is sent and the buffer is full, then this byte will be lost. No acknowledgement will receive. And this is the small packet. If it is lost, it's okay. It doesn't problem. If a big packet is lost, then a big data is lost. The bandwidth is used. Okay, so we send smaller packet. This host A will send smaller packet. If this packet is arrived, and you can see that when this packet is arrived, and now the buffer is full, so it will be accommodated in buffer. And the acknowledgement, when the packet is arrived and it is correct, the host B has to send the acknowledgement. So host A will send its acknowledgement, and when the acknowledgement is sent, then in acknowledgement the host B has to tell its receive window. So the receive window is 29, so this will be informed. So when this is informed, now the host A can send 29 bytes of data. So in this way, the host B comes to know about this free buffer space. Okay, so when host A receive window 0, so and the host A wants to send the data, then host A will send a small packet, of 1 byte. So if it is lost, so it is not a problem, it is a small packet. But if it is not lost and it is received and the buffer is available, then it will let us know that how much buffer is now free space available. Okay, so this is how this flow control works. So the TCP flow control, basically the receiver advertise free buffer space by including receive window value in the TCP header of receiver to server segment when the receiver is sending data to sender. And the receive buffer space, a receive buffer size set wise socket option. You can increase, decrease the receive buffer space. This is the receive buffer. So by default its value is 4096, but you can decrease and increase through using socket options. Okay. So many operating systems, they can also auto adjust the receive buffer space, that how much should be the receive buffer space. Sender limits the amount of unacknowledged packet data to the receiver's receive window. What does it mean? That when the sender receives the receive window, so the unacknowledged packets, they are subtracted from the receive window, and then the receiver, the sender, it can send that amount of data. Okay. So it means that the sender limits the amount of unacknowledged data to the receiver by subtracting the unacknowledged byte from the receive window. Okay. So it guarantees that the receiver buffer will not overflow. Okay. So this is the total buffer space, and this is the buffer data. So the buffer data, it will be removed, it will be subtracted from the receiver buffer, then this becomes the receive window, the free buffer space. Okay. So we have discussed the flow control in detail. I think it will be clear to you. Okay. So the receive window is this receive window field, it is used for the flow control, and this way the TCP controls the flow control. Okay. In this way the TCP controls the flow. In this way the TCP avoids the overflow of the receiver buffer. Okay.